Hi everyone, this is Mrs. Guile. The purpose of this video is to fill in your speed, velocity, and acceleration notes that are part of your Motion Hyperdoc notes packet. So we'll start with speed. We're going to fill in the first box with motion. So the motion of an object can be measured. And then in the next box, we're going to write the definition for speed. Speed is the distance an object travels in a specific amount of time. You have to write kind of small because there's not a whole lot of room in this box. So speed is the distance an object travels in a specific amount of time. We can calculate speed using a formula. So speed equals distance divided by time. In this formula, distance is going to be measured in meters. The abbreviation for meters is a lowercase letter m. Time is measured in seconds. The abbreviation for seconds is a lowercase letter s. And so then if we combine those two units, meters and seconds, to get our speed unit, we'll say speed is measured in meters per second. And we would write this as lowercase m/s, like that. So we're going to do two examples of calculating speed. So we're going to use this equation, distance divided by time. So example 1, it says a snail takes 5 seconds to crawl across the ruler. The ruler is 10 centimeters long. So one of the things that I need to know for my equation is distance. Off to the side, I'm going to write d equals, his distance equals 10 centimeters. And I also need to know time in my equation. So t for time equals, it tells me 5 seconds. So if I do the math out for this, 10 divided by 5, so my speed will be 10 divided by 5. I know in my head I can do that math. 10 divided by 5 is 2. So his speed is 2 centimeters per second. But we just said that we want to do speed in meters per second. So I know that there are 100 centimeters in every meter. So I can convert 2 centimeters as being 2 out of 100. So that would be 0.02. That's 2 100ths meters per second. That would be my final answer. 0.02 or 2 100ths meters per second. Okay, example 2. It says a car drives 250 meters in 1 minute. So again, off to the side, I'm going to write my distance because I need to know distance. So the distance in this case is 250 meters. And then I need to know also my time. So off to the side, I'll write t for time. And I'm going to convert minutes to seconds right now. I know that there are 60 seconds in 1 minute. So I'm going to convert 1 minute to 60 seconds. So then my speed is going to equal 250 divided by 60. For this one, I'm going to use a calculator. So when I plug that into my calculator, 250 divided by 60 equals 4.1 with a repeating decimal. So I'm going to round this up to 4.17. So my final answer would be 4.17 meters per second. Okay, so let's move down to the next part. So now we have distance time graphs. So we can represent speed using a distance time graph. So in this box, we're actually going to make an example distance time graph. So we have these points in this data table to plot. We have distance on the y-axis, so I can actually make arrows at the top of this y, label it y. I have time on my x-axis. I can make an arrow at the end and label it x. And now I can plot these 2 points for this table. So I have 0, 0 as my first point. So actually, I'm sorry. First, we should probably make a scale going up the y-axis. So I can start with 0, and I know that for my distance, I need to go up to 16. So I can go up by 2s. So 0, 2, 4, 6, 8, 10, 12, 14, 16. Okay, I also need to make a scale on my x-axis for time. I know I need to go up to 10 seconds. So I can actually count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's better. Now I can actually plot these points. I already did 0, 0. So my next one, 1 second is 2 meters. So my time, my x-axis 1, and I'm going up to 2 on the y-axis. For my next point, I have 2 seconds and 4 meters. So 2 and 4 would be right here. And then I have 3 and 6. So 3, 6 would be right here. And then I have 4 seconds and 8 meters. So 4 and 8. Ooh, and then I have 5 seconds and still at 8 meters. So 5 seconds have gone by, but the distance this object traveled is still 8 meters. 6 seconds have gone by, and the distance this object traveled is still at 8 meters. 7 seconds, and it's still at 8 meters. 8 seconds, and it's still at 8 meters. And then at 9 seconds, it starts moving again. It goes up to 12 meters. And at 10 seconds, it has gone up to 16 meters. So I can now take a ruler and connect these dots to make a line. So here is my distance time graph or speed graph. In this graph, we can say that the slope of distance time graphs is the speed. So if I were to calculate the slope of this line, I would calculate the speed of this line. Let's talk a little bit about what this line actually means. So off to the side over here, it says a straight diagonal line means constant speed. So what do we mean by a straight diagonal line? So let's look at this. This part right here is a straight diagonal line. So we could make an arrow from this part to this little blurb of information. So at this point in time right here, this object is traveling at a constant speed. That means the rate that it is increasing is the same every second. So if I were to find the rate of increase for every second, I could go up 1, 2, and over 1 second, up 1, 2, and over 1 second. So every 1 second at this point in time right here, The object is traveling 2 meters. It goes from